graph show a displacement time graph. Okay, so displacement time graph. Okay, so which graph corresponds to a body at rest? Okay, so mean at rest means the object is not moving. Okay, so if the displacement is 5 meters, so it always stay at the 5 meter. Okay, so for number one, which one is the correct answer? Yeah, A. Very good. Okay, so the answer is A. Okay, for number two, okay, which graph corresponds to a body moving with a constant velocity? Okay, so we already learned two things, right? We already learned two things before. Okay, the first one is the graph of displacement against time, right? Displacement against time. Okay, and then we know the gradient is represent the velocity. Okay, and then another one we learn about the velocity against time, right? And then the gradient is equals to acceleration. Okay, acceleration, and then another one, the area under the graph. Okay, area under the graph is actually equals to the displacement. Okay, all right. So let's see for the question now. Let's say I have a graph, right? So you want from displacement against time to the constant velocity graph. So the displacement against time, the gradient is equals to velocity. So let's say for A, can I draw any triangle here? No, right? So mean if I cannot draw a triangle here means the gradient is zero. So when the gradient is zero, okay, means the velocity also zero. Okay, and then for B, okay, if I draw the triangle here, okay, as you can see the triangle become smaller. Okay, so when the triangle becomes smaller means the gradient become smaller. Okay, so the gradient becomes smaller means V also become smaller. So this is actually the decreasing velocity. Okay, and then for C, okay, if I make a triangle, okay, if I make a triangle, you can see the size of triangle become bigger. Means the M is higher. Okay, M is higher. Okay, the gradient become higher, and also means the velocity also increase. Okay, and then for this one, if I draw a triangle here, the size of the triangle is always same. Means the gradient is same. So the gradient is same, the velocity also same. Okay, so for this one, constant velocity, the answer should be D. Okay, so this one is D. Alright, good. Okay, some of you got it correct. D. Okay, and then for the number three. So this one, they got many of you asked me this question. Teacher, which one is the constant acceleration? Okay, so from this one, this part question, you have to change from displacement against time to velocity against time, and then another one you have to change to acceleration. So means you have to change from another graph to another graph. Okay. So let's say for this one, okay, I go for A. Right, when the velocity is zero, means velocity is zero, the object is not moving. So of course the object is no acceleration at all, right? Okay, for B, okay, so I draw for B, there is a possibility because there's still got the gradient here. Okay, and then for this one also still got the gradient, and also D still also got the gradient. So I will draw these three graphs and I will show you how to transform from displacement against time to velocity against time. Then after that, we transform to acceleration against time. Okay, all right. Let's try first. Okay, so let's say this is displacement against time. Okay, displacement against time. So this is the graph, right? Okay, so then I have to change from to the velocity against time. Okay, and then the last one, I have to change to acceleration against time. Okay. Mhm. Okay, and then the first one, let's say for the gradient. Okay, okay, the gradient for the displacement against time, if I draw the triangle here, can see the size of the triangle is same. So means the size of triangle is same, the gradient is same. So the gradient for displacement against time is actually represented by the velocity. So you can see the side is same, gradient is same, velocity also should be same. So the graph should be like this. Okay, if you transform from displacement against time to velocity against time. Okay, and then how to transform from velocity against time to acceleration against time? We already learned that the gradient of the velocity against time is actually equals to the acceleration. So can I draw any triangle here? No, I cannot draw a triangle. So means the gradient is 0. So the gradient is 0 means the acceleration is 0. So if I have to change from velocity against time to acceleration against time, so the graph should be on the x-axis like this. Okay, so you have to draw like this on the x-axis. Okay, all right. So this is the first graph for displacement against time. Okay, what if I have? Okay, if I have this kind of graph? Okay, displacement against time. Okay, again you draw a triangle. Okay, so when you draw a triangle, the size of the triangle become bigger. Okay, so means the gradient is increasing. Okay, and we already know the gradient for displacement against time is actually equals to velocity. Okay, so if I draw the velocity against time graph, since the gradient is increasing, the velocity also should be increasing. So if I draw the graph for velocity against time, it will increase like this. Okay, can you understand so far until what I explained until now? All right, very good. Okay, and then how do I change from velocity against time to acceleration against time? Okay, then still the same method. Okay, you have to draw the triangle here. So when you draw a triangle here, you can see all the size is same. Size of the triangle is same, means gradient also same. And you already know the gradient of the velocity against time is actually equals to the acceleration. So if I draw the graph, the line should be like this. It's constant. Okay, since the size of the triangle is same, the acceleration also should be same. So it should be constant like this. Okay, and then we go to another type of graph that is like this. Okay, and if I draw the triangle here, the triangle become smaller, right? So means the gradient is become smaller. Okay, so the gradient becomes smaller means the velocity also become smaller. So if we draw the graph, it will be like this. Okay, for velocity against time. Okay, how about the acceleration against time? Okay, how about the acceleration against time? Okay, if I draw the triangle, right, it's a constant, right? You can see the size is same. Okay, so when the size is same means the gradient also should be same. And so the acceleration also should be same. But okay, this one, since the velocity is decreasing, so we call it as what? What do we call it? Anyone? You want to try? We call it as what? Yes, very good. Deceleration. So deceleration, you already know, is the A should be negative, right? Okay, so when the A is negative means the graph is at the negative uh, y-axis. Okay, so this should be the graph like this. Okay, for the negative part. Okay, are you clear now? Okay. So can you answer this question for number 3? So which type of graph? A, B, C, or D? Yes, very good. Okay, so the answer should be C. Okay, so we put here C. Alright. So we go to the next question. Okay. The following graph are velocity time graph. Okay, so which graph is correspond to a body moving with constant velocity? So the answer is constant velocity or uniform velocity A. Yes, very good. A. And how about moving with constant deceleration? Yes, D. Good. Okay. And then next one. Okay. So for number 6, right? For number 6, the graph shows displacement S, okay, of an object changes with time. Okay, and then ask you to find which velocity time graph represent the same motion as the object. So remember, I said draw triangle, cannot draw, right? So means the velocity is 0. So of course this one is wrong because it's supposed to be at the x axis here, right? Okay, and then for this one, okay, can you draw the triangle? Yes. And then you can see the size of triangle is same, means the gradient is same. Okay. So when the gradient is same means the velocity is uniform or constant. So it should be here like this. Okay. This one also already wrong, right? Okay. And then this one is actually should be at the negative part. So the answer should be at C. Okay. Did you got this one correct for number 6? Okay, good. Okay, for number 7, they ask you to do a number 7, no, right? 1 and 6 only, right? 1 and 6 only, right? Okay, good. Alright, so we move on to the next one. Okay, so this one, okay, for this part. Okay, the structure. Okay, in the exam, for paper 2, okay, this will be the example for the structure question. Okay, structure question, section A. Okay, for section A, remember they got 8 questions. Okay, that you have to answer all of it. Okay, then for section B, you can only choose one. Okay, and section C, only one question, cannot choose. Okay, so it depends whether form 4 or form 5. Okay, we don't know, right? Okay, so let's say for this one is SPM 2015. Okay, question number 7. Okay, so you can see a student is running a 200-meter event. Diagram 7 shows the distance time graph to illustrate his running. Okay, so this is the graph. Okay, and then the first question asks, okay, tick the correct answer in the box provided. Okay, so distance is what? Scalar or vector? Distance is scalar or vector? Yes, scalar quantity. If displacement, that one is a vector. Okay. Okay, for B1, based on diagram 7, calculate the speed of the student at section AB. Okay, at section AB means at this part, right? Okay, so if you want to calculate the speed, okay, for this one is speed. Okay, so means you have to find the gradient because they use distance here, right? So means the answer, the gradient should be it represent the speed. Okay, so what is the teacher? This one, the teacher post in GC. I think so. I posted. I didn't post it. Is it? Anyone? Wait, I check first. I think I post already 2.1, right? Wait, teacher check first. Um, 2.1. Tutorial 2.1. Yeah, I already posted yesterday, I think. Yeah, yesterday I posted in the TC. Oh, this one, the question, the structure. I only post the objective part. Okay, sorry. But did you, if you teacher, I think you only posted. Oh, really? 4S? I thought 4S, 4M, and 4K is one group. GC, right? I make in one group. I didn't, yeah. But for those, they have this question, means they go take at the postcard there. They take the hard copy from the card post there, because if they take from the card post there, I already printed off. Yeah. Okay, so you only have an objective part. Alright. So is it okay if I just majority took from the school? So that's why, maybe that's why they have it. Okay. So it's okay. Later I will post in the GC again. Yeah, yeah, yeah. I stapled it together. Okay, sorry, I didn't notice about that. Okay, so later I will post the structure question for you. Okay, in the GC. Okay, it's up to you if you want to print it or not. Okay, if not, then it's okay because only one question. Right, only one question only. If not, we just discuss. Is it okay? Right. Okay, so let's see for the next one. Okay, calculate the speed. Right, so the speed is the gradient. So first, what I have told you before, you have to put the coordinate here. So 1400, and this one is 24 200. Okay, this one is xy y1, x2 y2. Okay, and then what I said before, we have to draw the triangle. So how to draw a triangle? Like this. Okay, so this will form the triangle here. Okay, so this will form a triangle here. Okay, and then next one you have to use the formula 200 minus 134 minus 14. Okay, so I just put here 200 minus 124 minus 14. So what's the answer? 10 ms negative 1. Yes, very good. Okay, and then you have to compare. How to compare the speed OA and AB? Anyone know? How teacher want to compare? There are two ways, right? The first one, you have to use the formula. Okay, and then the second one, you can just look. Okay, you just can look the gradient. How, which one is the gradient is higher? This one, right? You can see the gradient here is higher than this one. Okay, so actually AB is higher, the speed is higher. Okay, if not, you can calculate. So let's say if you don't know how to see, okay, I teach you. Alright, so this one is 100 minus 0, 14 minus 0. So what's the answer? 7.14, right? Okay, so 7.14. Okay, so this means this one is higher. Okay, the speed for AB is higher. Okay, so you just put here how to answer speed of AB is higher. Okay, for the comparison question, you have to put like this: speed of AB is higher. Don't put higher only. Put in the full center like this: speed of AB is higher. Okay, don't put AB is higher. Okay, you have to put the what is the physical quantity that being compared. So this one is speed. So speed of AB is higher. Okay, for numbers for C, right, based on the following aspect, give suggestion on how the running time for 200-meter event can be shortened. Okay, so the first one, the student attire. So, any idea? Any idea? How can I increase the speed, or how can I increase the acceleration? What the student need to wear to increase its acceleration? Any idea? Yeah, the sports attire. So what is it? Trap bottom. Yes. Okay, alright. Yeah, that's correct. But okay, actually you have to describe the characteristic. So usually, they wish wear the tight, right? Yeah, lighter, good. Okay, light clothes, right? Light material, okay, or tight, right? So it will decrease the frictional air. Okay, so for this question, you have to describe the characteristic of the material. Okay, because I noticed some of you they put the name of material, polyester or something like that. Okay, don't put the name of the material. Okay, put the characteristic of the material. Why you choose the polyester, right? Yes, spot is wrong. Spot as tire is wrong. You have to describe the characteristic. Why you choose spot as tire? Because it's light. It makes from the light material, right? And then how do you wear it? You wear it tight. So that one you can decrease the frictional force. Okay. A tire should have an air pocket to reduce resistance. No, no. Don't put air pocket like that. Okay, that one will increase because the air, right? You increase the surface area. So when you increase the surface area, the air resistance also will be increased. Okay. So that one you just put light. Okay, light material. Okay, don't put the name of the material, canvas or whatever. Don't put the name, but put the characteristic. Okay, so and then whether the another one is tight. Okay, so to reduce air friction. Just simple answer. You don't need to explain too much, too long. Okay, the sentence no need to be too long. Just a very simple sentence. Okay, reduce air friction. That's all. Okay, you don't need to explain reduce air friction. Then we will increase the acceleration since the air resistance is reduced. No need. Okay. Okay, and then the student shoes. Okay, the student shoes. How about the student shoes? Sport shoes. Okay. Another answer. Aerodynamic shoe is spike. Mm, aerodynamic, I'm not that sure, but yeah, spike is yes. Okay. Shoes with spike. Okay. So why you need spike? Any idea why? Why do you need to have spikes? Yes, to increase the grip force. Increase the grip force. Yes, not slippery. Very good. Okay. Better grip force also can. Okay, and then the equipment used at the starting line. Okay, usually before they run, they will be like sit like that and then they put one feet right at the back there on some material there. So what is the call? Yes, the starting block. So why we using the starting block? Why not just run? Why you have to put the feet on the starting block? Speed. Yes, actually the terms that right is to increase the momentum. Yeah, to increase the momentum. Okay, to increase the momentum. Okay, this one you will learn later. But this is the yes. Ketiga, yes, to create, it's not to create, okay, even if you already start, because actually momentum, this is only the basic thing before we learn later, right? Momentum is actually every object that moving, they'll surely have the momentum, okay? So whether they don't use the starting block, okay, they just run also, okay, they already still have the momentum. But okay, if you have a starting block, okay, they will give you another force, okay, that move forward, okay, more forward force, okay, that means your momentum will be higher, right? So that one we learn later, okay. So any question you want to ask? Okay, so this is the answer. Okay, so you can compare this answer for those who already have answered this one. Okay, you can compare. Okay, you can see the sentence, very simple sentence. Okay, no need to put like essay like that, no need, because it's only 1 mark for each questions. Okay, right, good try. Okay, so we move on to the next one. Okay, I think I stopped until here, right, yesterday, so we continue here. Okay, all right. Can you answer number 3? Okay, can you answer number 3? I give you like 2-3 minutes, okay, to answer, then I will explain about this one. Okay, so this question you can see what is the difference. Okay, when the question asks you to find the distance, another one to find the displacement. Okay, so you will see the difference. Okay, this one you have to divide first. Okay, for me I will divide into A, B, C, and D. Okay, so triangle, trapezium, rectangle. Okay, and this is trapezium. Sorry, this one I make it as trapezium. You can divide also this trapezium into rectangle and also triangle. Okay, and this one also you can divide. Okay, this is the triangle, this is the rectangle. If you are not very good in using the trapezium formula, okay, if you can use the trapezium formula, then you just can have four section. Okay. Right? Okay, so can I get answer for anyone? 4 to 5, 4 to 5. Always the same people answer. Hmm. Yeah, give answer. Okay. Yeah. If you don't know, you cannot type, you can just open your mind. Alright, good. Okay, so I will come from for section A first, right? So A is a triangle, half multiplied by 10 multiplied by 20. So you get this one, 100, right? Okay, and then B, this one is a trapezium, half. Okay, and then 10 plus 20. Okay, 10 plus 20 multiplied by the height is 10. Okay, so 5, this one is 450. Okay, C, okay, this one also trapezium, half. 10 plus 15 is 25. Okay, and then times the height here is 10. Okay, so 1, 2, 5. And then the last one is D. Okay, for distance, ignore the negative. Why ignore? Anyone know why you have to ignore the negative? Why you have to ignore the negative? means going back. It's distant. Distant is a scalar. Right, good, Erin. Yeah, the answer is because distance is a scalar. So we ignore the direction. Okay, for those who answer distance is a scalar, okay, distance has no direction, that's a good answer, right? Okay, so D is half multiplied by 10 and also negative 10 here. So you will get negative 50. Okay, then what you have to do, you have to add all the value here. Did you get same answer? 100 plus 150 plus 125 minus 50. Hmm. Minus. Wait. Distance you have, don't ignore. You have to take. You ignore the negative. Why I take the negative part? Wait. Yeah. Okay, I cannot erase it. So what I have to do is, okay, so this one should be for 50, right? Okay, sorry. So this one should be 375, isn't it? Wait, 100 plus 150 plus 125 plus 50. Yes, 4 to 5 meter. Sorry. Okay, and then for this one you have to, I just calculate the D part, okay? Because A, B, C is actually same, only the D part is different, right? So I just calculate D because D is you have to take the negative because the displacement is the vector, right? So half multiplied by 10 multiplied by negative 10. So you got negative 50, okay? And then you just add all the area there, 100 plus 150 plus 125 plus negative 50. So the answer should be 375, 3 to 5. Wait, I calculate 100 plus 150 plus 125 plus negative 50. Yeah, 3 to 5. Okay, 3 to 5 meter. Is it clear? 3 to 5 or 375? 150 to 5 minus 3 to 5, right? Okay. 375 before you minus with 50, I think. Okay. Yeah, 3 to 5. Okay. So any question you want to ask, remember, right? So for this one, distance, ignore the negative. Displacement, have to take the negative. Okay. Alright, so let's move on to the next one. Okay, this one is actually already explained. Okay, I already explained before. Remember the graph displacement against time. Okay, for this one, I cannot make a triangle. Okay, for this one, I cannot make a triangle. So means the gradient is 0. So gradient is 0 means velocity is 0. Okay, so velocity is 0. Okay, there is no graph for A against T because velocity is already 0, right? Okay, and then this one when the graph is directly proportional like this. So if I draw the triangle is same. So means the size of gradient is same. The velocity should be same. Okay. Then this one I cannot draw the triangles, mean the gradient is 0. So gradient for the graph velocity against time, it represents the acceleration. So the acceleration should be 0. Okay. So this one I cannot draw a triangle. So gradient is 0. So the acceleration also 0. And how about when the S is decreasing like this? Okay, so S is decreasing, is still uniform. When you draw a triangle, the size of triangle is same, right? Means it's a constant, okay? But since it's going down like this, okay, so it should have a negative value, okay? So means that this one, the object turns back, okay? Turns back. So the velocity is negative. Alright, so the next one is, if you want to draw the A against time, so you cannot draw the triangle here, so means the acceleration is 0. Okay, this graph I already explained this now, right? Okay, the gradient, if you draw the triangle, the size of triangle is increasing. Okay, so thus the velocity will increase. So when the velocity is increased, if we draw the triangle, the triangle will be same, the gradient same, and this is velocity against time, and it represent the gradient represent the acceleration. Since the gradient same, acceleration also should be same. Okay, and then how about the deceleration? Okay, so this is the graph. Okay, so I draw, okay, like this before. You can see when you draw the triangle, the size of triangle is decreasing. So means the gradient decreasing, the velocity decreasing. Okay, but for this part, the velocity, when you draw the triangle, the size of triangle is same, means it's constant value. But since the graph is going downward, okay, decreasing, this one is actually deceleration. So A should be at the negative part of the y-axis. Okay. Okay, any question you want to ask for the graph? No. Okay. Okay, if you have a question, you can ask teacher. Because what I want you to do now, okay, I will stop our class until now, okay, until here, okay, and this one, the next slide, okay, until the last slide, I think, okay, you have to do it as your homework, okay, and also the tutorial questions, okay, the tutorial question, this one. Okay, remember that we still haven't answered a few questions, right? From tutorial 2.2. Okay, so you have to answer this one, tutorial 2.2, and also the question from the notes. Okay, okay, but I want you to submit. Okay, I just want you to do. Okay, but this one you have to be honest with me that you have to answer, because later if teacher discuss, then you are not like you didn't understand anything because you never tried it, right? So teacher, we don't have tutorial 2.2 I didn't give it yet. I give 2.2 only. 2.3 is free fall, right? Yeah, free fall I already asked, I already sent to the school. I will give on Monday. You can come to school to take on Monday. Okay? This one I already asked you to do tutorial 2.2 only. Okay, 2.2, and also the notes that I given. You have to complete all the exercise, tutorial 2.2, and also exercise on the notes. Okay, so are you clear? So let's say if you want to ask teacher, but make sure you answer first. Don't give me like, teacher, how to do this? Okay, try first. Okay, try first, then I will see whether it's wrong or correct. So then if I can guide you, I will guide you. Is it okay? If not, you wait for the next week class. Okay, so as usual, our first period will be the tutorial discussion. Okay, and then I will continue to our lesson. Okay, so I hope I don't want to like finish until 2:30. I know you're already tired. So teacher, before in difference, okay, I will put free fall and inertia in one set. Okay, free fall and inertia one set. Usually I will give like two topics like that. Okay, and tutorial also I will give two topics like that. Okay, so I put on Monday. Okay, at school so you can come. Okay, so I think I give you already, right? Because AC structure only one question for tutorial 2.2, so I don't need to give you at AC. I think we already discussed, so you just can listen from there, right? So anything you want to ask before I take my class? No, alright. Okay. So see you. Take care. Okay, have a nice weekend. Okay, bye. Take care. Yeah, bye.